Welcome to ZaranTech on SAP Commerce Cloud Data Model. In this video, we are walking you through the key aspects of data modeling in SAP Commerce Cloud. Let's start with a quick disclaimer. The information in this presentation is for informational purposes only. Please comply with all copyright laws and provide proper attribution for any images used. In this video, we'll cover Hybris HSQLDB tables and the overall data model structure, Hybris conventions for deployment codes, how to create tables in Oracle, managing different data types across databases, items.xml and its purpose, why object class is the superclass, dynamic attributes and index creation, item types in Hybris, storing collections in the database, redeclarations in items.xml, Hybris database internals for creating tables. Let's start by looking at the Hybris HSQLDB tables and overall data model. Hybris uses an embedded HSQLDB database by default. To view the tables, you can download the Squirrel SQL client, install the HSQLDB driver into the client, connect Squirrel SQL to the Hybris HSQLDB database. Browse the tables under the public schema. This allows you to inspect the table structures and data. At a high level, the Hybris data model consists of type system, defines item types, attributes, relations. Database layer creates database structure. Service layer provides database access services. The data model helps in database design and handles connections and queries. Data modeling in Hybris involves creating the database structure using the type system, analyzing the structure to meet project requirements. The key components of the type system for data modeling are atomic types like string, integer, collection types like list, set, enum types for predefined values, map types for key value pairs, relation types to define associations, item types representing entities. Deployments in Hybris refer to separating item types into different database tables. Some conventions. Commons extension uses 132XX codes. Print extension uses 234XX, 239XX codes. Process engine uses 327XX codes. Xspring legacy uses 244XX, 245XX codes. B2B Commerce uses 10xxx codes. This segmentation improves performance and isolates concerns. Here we see an example of item types assigned to different deployments based on the deployment conventions. Some key capabilities of the Hybris data model: flexible design using item types and attributes, separation of item types through deployments, built-in localization support, monitoring through audit tables, dynamic addition of attributes. This enables agile and scalable data modeling. To create a table in Oracle, we can use standard SQL DDL. Create table persons, PID char4, LNME varchar 255, FName varchar 255, address varchar 255. To manage different data types across databases, Hybris uses items.xml. This contains the logic to create tables and define structure. At runtime, Hybris generates database-specific DDL based on items.xml. This provides consistency across different database backends. Items.xml requires an accompanying item.xsd file that defines the XML schema. This provides the base structure for defining entities. At runtime, Hybris generates database-specific DDL based on items.xml. This provides consistency across different database backends. Some key points about items.xml. The item type itself extends item. An XSD file defines the rules. Item type instances go into the items table. Item type definitions go into compose type. Generic item is the default parent for item types. This provides a standardized structure. Object class is the superclass in Hybris for several reasons. Enables extending one item type from another. Allows controlling attribute access via modifiers. Controls table generation. Generic item is default. Provides default deployment segmentation. This inheritance hierarchy enables effective data modeling. Here we see an example of extending the product item type from the generic item supertype. This allows inheriting common attributes. Modifiers allow controlling attribute access. Read-only, only getter. Write-only, only setter. Optional, not mandatory. This helps in designing the item types appropriately. This provides flexibility for database design. Dynamic attributes do not persist in the database. Instead, custom logic implements the attribute. You may only have a setter without getter in cases like setting a password initializing state on creation. The setter allows value population while the getter is omitted for privacy. You may only have a getter without setter in cases like connection properties, creation timestamp, immutable attributes. The getter allows reading, but setter would be illogical.
We can define a composite primary key by setting unique equals true on multiple attributes. This will create a combined primary key index spanning those attributes. Indexes allow fast retrieval. Adding proper indexes is important for performance. We can define default values for attributes. This sets a default when the attribute is not specified. Key elements of an item type definition. Code unique name. Extends parent type. Java class optional Java implementation. Deployment table name. Auto create/generate enable implicit creation. Abstract cannot instantiate. This defines the structure of the entity. Key elements of an attribute definition. Qualifier unique name. Type atomic, collection, relation, enum. Modifiers read-only, write-only, optional. Default value. Unique, indexed, part-off. This defines the item type's characteristics. There are three main ways to define item types. Without extending another type. Extending an existing type. Redeclaring an existing type with more attributes. We must define deployment when overriding the default deployment table. Segmenting item types across tables. Customizing physical database design. This allows tailoring the database structure. Collections allow storing atomic types like list string. Composed types like list product. Collections are useful for one-to-many relationships. Dynamic enums. Generated as extensible enums in Java. Can add values on the fly. Changing the flag requires a system update. Non-dynamic enums generate fixed-value enums. So prefer dynamic enums when extensibility is needed. Making an enum dynamic allows adding values at runtime by setting dynamic equals true. Non-dynamic enums have a fixed set of values. Dynamic enums provide more flexibility. Many-to-many relationships use a join table. For example, between product and category. Product to category contains product ID and category ID. Allows linking products to multiple categories. This avoids duplication while providing flexibility. For simple one-to-many cases, you can use a collection instead of a relation. For example, a category has multiple products. This can simplify the data model when the association is unidirectional. Redeclarations allow modifying existing types. Add new attributes. Change modifiers. Override deployment. This is useful for customizing standard types. Hybris DB internals for creating tables. It contains three important files. Drop DDL, DDL, DML. Key database constructs generated. Item type tables. Localized attribute tables. Audit tables. Property tables. System tables. This covers the core entities and metadata. Thank you for your time today. I hope this overview was helpful. Please subscribe to our channel for more informative videos on SAP Commerce Cloud.